Hey, how's it going everyone? Welcome to this video. Today we're going to have a look at just a couple of examples from chapter 9.4. So the first one we're looking at is example 8. So we've got give a trigonometry value using radian measure for the point P on the unit circle, which lies on the boundary between quadrants 2 and 3. So if we drew our unit circle, and we've got our quadrants Q1, Q2, Q3 and Q4, and we're looking for the point P, which is between quadrants 2 and 3. So we've got 2 and 3 here, it's on the boundary, so it has to be there. If we remember from our unit circle, we start from 0, we've got pi on 2 between quadrants 1 and 2, and then we have pi between 2 and 3. So point P will be pi radians. The second part says identify the quadrants the following angles would lie. So I'm just going to draw another circle. And we've got 250 for the first one. So in this time, we're actually talking about degrees. So I've got 180 from 0, and then I could go back to 360. This would be 270 and 90. So using our angles, well, it's obviously more than 180, but less than 270. So it would be roughly over here. So this would be 250. Next one is 400, obviously more than 360. So what I've actually done is I'm doing a full rotation up to 360. The difference between the two would be 40. So this angle in here would be 40 degrees, and the angle 400 would be in quadrant 1. Sorry, I should have labelled that as quadrant 3 before. The third one, 2 pi on 3. Might go back to this triangle over here. So pi would be half a circle, and I want 2 pi on 3. So think about it, cut into thirds, and I've got 2/3. So 2 pi on 3 would be over here in quadrant 2. The last one is minus pi on 6. So if you remember, we've got a minus angle, which means we're going to go backwards. And we've got pi on 6, which is just 1/6 of an angle. So that'll be in quadrant 4. I'm just going to make a new page for the last bit. And so give two trig points Q and R, and one with a negative value and one with a positive value. So if I draw the circle, and it has to have the same position as P, 250. So again, remember over here would be our 250. I'm starting at 0, so that would be up to 250. I'm going to go backwards first. So starting at that, they're after a negative angle. Starting at 0, I'm going backwards. And so I need to work out how far backwards I need to go. And it's almost the same as saying from 360 I'm going back to 250. So if I find the difference between those two, that will be the difference between 0 and going into the negatives. So this angle Q would be negative 110 degrees. And the other one is I need a value which is positive. So I could go 250 to start with to get to point P, and I want a positive value so I can keep going for another full circle. So adding those both together, I get 510 degrees. So I'm doing one full rotation and then an extra 250 degrees. Example 9, calculate the Cartesian coordinates of the point pi on 3 and show the position of this point on the unit circle. So pi on 3 is our angle that we're interested in, and Cartesian coordinates, x, if you remember, is our cos angle, y is going to be our sine of the angle. So we have cos of pi on 3 for our x value, and for our y value we have sine of pi on 3. If you remember our exact values, cos of pi on 3 is going to be a half, and sine of pi on 3 is the square root of 3 over 2. So our point P has coordinates 1 half square root of 3 on 2. So our point P is going to lie in quadrant 1 because both x and y are positive. Oh, it's a horrible circle. So roughly over here, we get square root of 3 over 2. Oops, other way around. This one's our square root of 3 over 2. This is our half on the bottom for x. So our point P is going to be over here, and pi on 3 is our degrees inside there. The second part says illustrate 330 degrees and sine of 2 on a unit diagram. So cos of 330 is our x coordinate of the trig point 330. And 330 is going to be, well, it's more than 270, so it's going to be in the fourth quadrant. Sine of 2, sine is our y values, so it's going to be sine of the trig point at 2. If we think about the values of pi, pi is roughly 3.14. 2 is obviously less than that, and half of pi is going to be 1.57 roughly. So we can say that the point 2 lies between pi on 2 and pi, and we can work that out using our unit circle. It's going to be between those 2 points there, so it's going to be in quadrant 2. So for each of these points on the diagram, The horizontal line will give the x coordinate and the vertical line will give the y coordinate. So our first one, and we've got cos of 330 and the second one is over here. So part C says use the Cartesian coordinates of the trig point pi to obtain the values of sine of pi and cos of pi. So angle pi is over here, and obviously this point here is going to be there. And we're after the sine and cos of that angle, which is pi. And if you remember, we've got our x coordinates is our cos, y is our sine values, and we're also sitting at the point minus 1, 0. So our x in this point is going to be minus 1, our y is going to be 0. So I can say cos of pi is going to be minus 1, sine of pi is going to be 0. And the last one, if f of theta is equal to cos of theta, evaluate f of 0. So f of theta equals cos theta. And I want to work out what f of 0 is, or in other words, what cos 0 is. 0 is over here. Again, that's our x coordinates. My coordinate is going to be 1, 0. That's my x coordinate, which is 1. Cos of 0 is going to be 1. Last example, we've got illustrate tan of 130 and use a calculator to evaluate. So we've got our unit circle, 130, a bit more than 90, a bit less than 180, so roughly over here. So tan of 130 lies in the second quadrant. And if we extend this line up until the tangent at that spot, we can say this point here is t. So t is going to be the extended radius. Point P to O intersects the tangent drawn at A. So the intercept AT is tan of 130. So the intercept lies below the x-axis, which shows that tan of 130 is negative. And if we work that out on our calculator, we get roughly minus 1.192. And the last bit, so the trigger point at P of pi is an endpoint of the rotation of 180 degrees, or at pi, which is over here. So it's the Cartesian point P minus 1, comma 0. In other words, x is minus 1, y is equal to 0. Since we know that tan of an angle is our y over x, we have 0 over minus 1, which is just 0. So that's all for the examples on 9.4. Have a go at the questions. Thanks for watching.